Hi guys, good afternoon. Today I would like to share the third lesson in sequence control. Now using simplified flow charting. And today I want to share you what I did in the past to configure sequences. No, especially even difficult sequence, we can do it in PLC in a very easy way. So I devised a system, I call this simplified flow charting, wherein I only reduce our symbols because I'm not a computer engineer. So I do it on my way. No? I did it my way. Gaya sabi ng iba. Okay, action initiators or motion initiators, I represent it with circle. Motion or action is the rectangle and the arrow is the next step. Invert is the symbol if you want to invert something like in the Boolean algebra, it means not. For example, if switch is represented by S1, I can write it not S1 or a bar at the top of S1. Okay, so I want to share to you what I did in my simulation, and I will show you how I program it in my PLC. Okay, so I will share this, and this is how we're going to do sequence on this project. And I show you, we have a conveyor 1, conveyor 2, exit conveyor. This is entry conveyor. So we have two motors, 1, 2. Also, we have a transfer conveyor here, wherein you have a motor to push the box on this transfer area or transfer table. Then we have to rotate. We have to rotate. So you have two motors in this transfer area. So the motor to transfer from conveyor 1 to this transfer table. Then you will rotate it. You have a device to rotate it, probably motor or with gearbox or a pneumatics is possible, but this is a motor with gearbox. So I can reverse it and I forward it. Okay, so all in all, you have 4 motors, and I have entry sensor here, this one, entry sensor, and I have an exit sensor here. Okay, so first you have to organize what you want to do. Of course, you want to do is to transfer this box to this. Then afterwards, it passes through the sensor. It will rotate and will stop the conveyor so that the packages will not go in. There's so many packages in the conveyor. So as we'll show you what I want to do, this is what I did, and I will show you how do I did the program. First, you can see how it looks. Okay, this is a sequential control. This is sequential control. Okay, pass the sensor. Then the conveyor stops. And it hit the limit switch. And rotate. Then reverse the transfer so that the package will do here. Okay. Pass to the second conveyor. Okay, and after it pass, it will again go to that go back. Then at this then it will pass again. So we call this a sequential system. So in what we call flow chart, no, I want to show you the flow chart for this. So easy like this. Okay. Then like what? Okay. This one, no, sequence control demo. You have the post button. Then conveyor 1 will run. After running the entry conveyor, exit conveyor will run. Then it will hit the S2, which is entry sensors. Then transfer forward. Okay, this is the motor, transfer forward. You see? Transfer forward here on the right. Then after transfer forward, it will hit S3, which is the turntable back sensor. Then reverse, not CB1. It means you have to stop conveyor 1. Okay? Means not CB1, you have to stop CB1. Then it will reach S3 again. Sorry, it will S3, still in the S3. Turn. Then you have to turn the table. Okay, rotate. Then it will hit the limit, which is S4, which is the at 90 degrees sensor. It will transfer reverse. Okay? So after transfer forward, it will transfer reverse. Of course, you must do the proper interlocking of reverse and forward here on your system. Then, not S6. It means at XC sensor, kapag lumagpas na, if the box will pass through the sensor, it means it's not sense. Then reverse the turn. Okay? So you turn, then not turn, then S5, then you have to reset the cycle. This is how to do the sequence. So if I do this in my PLC, it look like this. Okay? This one, okay? So as you see, every square is here. After cycle start, run conveyor 1, then run turntable negative, which means forward. No? Sensor at entry, run. Then next is stop entry conveyor. The next step is run turntable. Then the next step is run turntable positive, which means you have to reverse the turntable. Then after I sense the pulling edge of the retroreflective sensor on the exit conveyor, that's why I have this entry. No? It means negative trigger, which is you sense the pulling edge when the box passed through the sensor, and after it passed, then next you have to release the turntable to go back again. Then the last step is reset. This is your sequence, as easy as this. Then you just assign the bit to its output. Cycle start, stop light, then entry conveyor, exit conveyor, turntable 1, turntable positive. And the nut here, or the negative, normally closed here, is the one who will stop your conveyor. So run turntable bit will stop your conveyor, stop entry conveyor will stop your conveyor. This is how it is done in practice, in easy as that. So if I do this, I online this, like this online system, you can see. And now it's online. It means we are connected to my factory IO simulator, and I show you again my factory IO. And this is how it works. Okay? So I start the motor. As you can see, I can easily terminate. Okay, so pass through the turntable, turn. So what we do is a sequential step of a program. We call that step change, the domino effect, or the domino sequence. We call this the linear cascading technique to do in programming. So that is how to do programming. You must have a system to do program, not like inductive programming. It's easy to always have a system. I developed my own system. It's called Simplified Projecting, and I can do a lot of programming in my PLC. Okay, so thank you for subscribing.